Hello guys, in this video we are going to discuss the solution of the problem three-way partitioning. So let us look at the problem statement. The problem statement says that given an array of size n and a range a to b, the task is to partition the array around the range such that the array is divided into three parts. All elements smaller than a comes first. All elements in the range a to b comes next. All elements greater than b appear in the end. The individual elements of three sets can appear in any order. You are required to return the modified array. So let us try to understand the problem statement with the help of an example. So let us say the array which is given to us is 8 and the content of the array are, and the range which is given to us is 3 to 5. So this is one possible way to arrange the array. Please note over here all the elements less than 3 are appearing in the first portion of the array. All the elements in the range of 3 to 5 are appearing afterwards, and all the elements which are greater than 5 are appearing towards the end. So this is one possible way to arrange the array, and once we return this modified array to our driver code, the driver code will return 1. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is to identify all the elements which are less than a. If the elements are less than a, what we are going to do is we are going to move it towards the beginning of the array. Similarly, if the elements are greater than b, we are going to move it towards the end of the array. And in the case where the elements are in the range, what we should do? If the elements are in the range, then in that particular case, we are not supposed to do anything. So if we follow these three conditions, we will be able to partition the array such that all the elements which are less than a are at the beginning of the array, all the elements which are greater than b are towards the end of the array, and all the other elements are in between. So let us formalize these three cases. So the first case is if a array of I or the ith element is less than a. If this condition is satisfied, we will do something. The second case is if the elements are greater than b. And the third case, which is pretty straightforward, if the elements are in the range. If this condition is satisfied, then in such cases we don't have to do anything. We will just move our iterating counter to the next element. So for the third case, it is pretty obvious and it is clear. Now let us see what we are going to do with the first two cases. Well, in the first two cases, like we have mentioned, we would like to move the element towards the beginning in the first case, and in the second case, we will like to move the elements towards the end. So for that reason, we will have two pointers with us, which is less than pointer, and initially we are going to set it to 0, and then there will be another pointer which is greater than pointer, and here the value will be equals to n minus 1. So with the help of less than and greater than pointers, we will be able to divide the array into three parts, and all the elements in the range from AR 0 to less than minus 1, all these elements are less than a. Similarly, all the elements from the range greater than plus 1 all the way till n minus 1, all these elements are greater than b. So this is what less than and greater than pointer signifies, and this is how we will be able to partition the array with the help of these two indexes. So now let us work with an example in order to understand how we will be manipulating the array with the help of less than and greater than pointer in order to achieve to our solution. So let us take the same example which we have, where the array which is given to us is this, and the range which is given to us is 3 to 5. So let us see how we will be able to do it with the help of less than and greater than pointers. So this is the current state of the array, and I have designated the indexes as well. And let us now set our pointers. So our iterative counter is at 0th position, which is over here. Our less than pointer is also at the 0th position initially to begin with, and our greater than pointer is towards the end. So this is where it is. Now let us operate on the ith pointer. So here 8, we are going to check whether 8 is in the range or not. So as we can see that the range is 3 to 5, 8 is clearly greater than 5. So 8 should be moved towards the end. So what we are going to do is we are going to move 8 towards the end. So 8 will come over here and 4 we will bring it down towards the beginning. And all other elements remains as it is. Once we have done this, now is the time where we will go ahead and manipulate our 3 pointers which we have. Since we know that we have already copied a greater than element towards the end, because of which we are moving this pointer by 1 position. So the greater than pointer will be moved to this point. And the other 2 pointers remains as it is. We will not modify the other 2 pointers. So the less than pointer is here and also my iterative pointer is here. So once we have done that, now we'll move to the next iteration. Again, 4, as we can see that 4 lies in the range of 3 to 5. Since it lies in the range of 3 to 5, we are not going to do anything. We will just move our iterative pointer to the next position. So let us do that. So let us move our iterative pointer to the next position. So my iterative pointer is here. Less than and greater than pointer remains as it is. Now again, we will compare 7 with the range 3 to 5. As we can see that 7 is greater than 5. So 7 has to move towards the end of the array. So let us move that. So 7 will come at this position. 6 will be over here and all other elements will remain as it is. As we have done before, since we have copied a greater than elements towards the end, so the greater than pointer has to be reduced by 1 and it will be moved to this position. All other pointers remains as it is. Now let us repeat the same process again. 6 is greater than range, so 6 has to be moved towards the end. So 6 will be over here, 5 will be over here and all other elements remains as it is. Since we have copied a greater than element towards the end, so we have to move our greater than pointer by 1 position. So now the greater than pointer is at this position and other pointers remains as it is. Now let's operate on 5. Now since 5 is in the range of 3 to 5, so we will not do anything. We will just move our iterating pointer to the next position. So let's do that. So let's move our iterating pointer to the next position and my less than and greater than pointer remains as it is. Having done that, now let's operate on the next element, which is 1. As we can see that 1 is less than the range 3 to 5. So 1 has to be copied towards the beginning of the element. So 1 has to be copied towards the beginning of the array. So let us do that. So 1 will come over here, 4 will be there and all other element remains as it is. And since we have copied a less than element towards the beginning, because of which we will move our less than pointer by 1 position. So my less than pointer will come over this position and all other pointers will remain as it is. So my iterative pointer will be here and my greater than pointer will be here. Now let's operate on the ith position. So the next element is 4 and 4 is in the range of 3 to 5. So we will not do anything. We will just move our iterative counter to the next position. So let us do that. So let us move our iterative pointer to the next position and my less than and greater than pointer remains as it is. Now let us operate on the next element which we have. The next element is 3. 3 is again in the range of 3 to 5. So we will not do anything and we will move our iterative pointer to the next position. So let us do that. So let us move our iterating pointer to the next position. So over here and the less than and greater than pointer remains as it is. So the next element is 2 and 2 is less than 3 to 5 or 2 is less than 3. So we need to move 2 towards the beginning of the array. So let us do that. So 2 will come at this position, 5 will go over here and all other elements will remain as it is. And once we have done that, what we need to do is we have to move our less than pointer by 1 position. So our less than pointer will be over here and the other 2 pointers will remain as it is. Now 5 is again in the range of 3 to 5. So in this case, we will just move our iterative counter to the next position. So let's do that. So the less than and greater pointer remains as it is, but the iterative counter has been moved to the next position. Now the question comes over here is, should we operate on 6 or not? Now as we already know that all the elements towards the right of orange is greater than B. Since we already know that, we don't really have to operate on any of these elements. So in a sense, what I'm trying to say is iterate till I is less than or equals to greater than pointer. And this is where we will end our loop. So now if you see, we have partitioned the array into 3 parts such that all the elements of 3 to 5 is over here. All the elements less than 3 is towards the beginning of the array, and all the elements which are greater than B is towards the end of the array. So this is a possible arrangement, and this is the modified array which we will have, and we can return this. So that's about the explanation, folks. Now let us look at the pseudocode for this problem. So let us say we want to perform three-way partition, and array is given to us and the range A to B is given to us. So initially what we are going to do is we are going to set our pointers. So I is equals to 0, less than equals to 0, and greater than equals to n minus 1. And let's say we have n also. So these few variables which we have, and now let us iterate on all the elements of the array. So as we have discussed above, that we will be iterating while I is less than or equals to greater than. Now what we are going to do is we are going to check whether ARRI is in the range or not. If it is in the range, then we don't have to do anything. We just have to increase our iterative counter to the next position, and from here we can continue, which simply means we'll move to the next element. Otherwise, if this condition is not satisfied, we are going to check whether ARRI or the ith element is less than A or not. If it is less than A, then we have to move towards the beginning of the array. So let us perform a swap operation. So we will perform a swap operation between ARRI and ARR less than. And once we have performed the swap operation, we have to move our less than pointer by 1 position. Over here there is one more peculiar case which we did not cover while going through the example, but it might be possible that my ith position is equals to less than position. So less than, and I'm minus 1 because I have already increased less than by 1. So that's why I'm essentially over here I'm checking whether I is equals to less than or not. But since I have already increased it by 1, less than, I have already increased it by 1, so that is why I'm decreasing it by 1 and then comparing it. If I and less than are at the same position, then we also have to move our ith pointer by 1 position. Otherwise, the element will be greater than B. In such case, we have to move this element towards the end of the array. So let us do that. So we will perform a swap operation between the ith element and the greater than element. And after doing that, let us decrease our greater than element by 1. And once this is done, we will return our array. So that's the pseudocode, folks. Now let us see how we have implemented this in Python. So the code is essentially the same as what we have discussed in our pseudocode. I equals to 0, n equals to length of the array, and then there is a less than pointer and a greater than pointer, and the values are 0 and n minus 1 respectively. And we are iterating on all the elements of the array while I is less than or equals to greater than. If the ith element is in the range, then we are just moving to the next element and we are continuing from here. If it is less than A, then we are performing a swap operation between less than and the ith element, and we are increasing our less than by 1, and ith will also be increased by 1 if less than equals to I. In the case where ARRI is greater than B, we will perform a swap operation between ith and greater than element, and then the greater than element will be decremented by 1, and towards the end we will return array. So that's the code, folks. Now let us go ahead and submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.